Welcome to the video over section 6.3, and what these are exponential functions. Exponential functions basically means the variable is in the exponent, and we're going to be looking at the graphs and how to use the transformations like we've looked at in the past. The rules do not change in any way, shape, or form. And we're going to look at how to use the calculator to get potential answers for some of these problems. And in fact, we begin with number 1. It says approximate the value using a calculator and express our answer rounded to 3 decimal places. And so most of you already know this, but just to show how to use the exponent on the graphing calculator, what we're going to do is we have 5.198. So we've got 5.198, and then we're going to use this button right there. That is the raised, or the power, and then 1.793. Now most of you will have an actual caret on your screen, and then it will say 1.793 right next to it. Realize if you do have this app that I have, it will show up like that. I honestly think this app is more of a pain than the old way. And then just hit enter, and we see that the answer should be 19.209 when we round it to 3 decimal places. So as a result, number 1 is 19.209. Okay, number 2, we are given the graph of an exponential function. You'll notice that it looks somewhat similar to the reciprocal function, except one very important thing about exponential functions is we start out with, at least, going through the point 0, 1, because we know anything raised to the 0 power is equal to 1. And so 0, 1 is always one of the points that we get. But if we look at number 2, we're going actually through the point 0, negative 1, which means our base, the base of our exponential, has to be negative. So that means the answer either has to be A or B. It cannot be C or D because 4 is not negative in those cases. And then it's a matter of, does it look more like this or does it look more like this? And in actuality, a normal exponential function will look like this. It goes up very steep on the left, it goes through the point 0, 1, and then it goes over like this. So the negative 4, or raising to the negative x, that reflects it over the y-axis. So that means if we would have a negative x, that rule doesn't change. So we'd get something like that. But the negative 4, that's not directly connected to the x, reflects it over the y-axis. And so we get this thing that looks like that. And this is the final result if we take negative 4 that would be negative 4 raised to the negative x power, wouldn't it? So because it required this reflection over here, which was the negative x, and there was this one over the y-axis, required this 4 to be negative. And so as a result, the final answer should be A. The answer is A, negative 4 raised to the negative x power. We will spend more time on these actual graphs here shortly. Number 3, we are asked to graph the function. That function being quantity 1/4 raised to the x. Okay, now the x, there's nothing special that's I mean, it doesn't reflect over the y-axis. We don't need to shift it or anything like that. And so we should realize as a result of that it will go through the point 0, 1. So we need to take care of that. And then we do a few others. Well, here at 1, if we just plug in a value, 1/4 raised to the 1 is 1/4. So that's going to be there. And it's just going to get progressively, very quickly, closer and closer to 0. Coming back here to the -1, well, 1/4 raised to the negative first power simply means take the reciprocal of this. So that means at -1 it's going to be 4. So we've got that point. So we have 3 points. We understand that it looks like this sort of curve, and this was not very good, and it's never going to reach, or it's never going to reach the x-axis, but it technically goes forever and ever in this direction, just very slowly towards the negative x value. Now we have to go back to the calculator. It says approximate the value using the calculator. And in order to do this, we need to find the e to the e button. Now the value for e on the Texas Instrument is really an e to a, or no, wait a minute, we can take e, that is second divide. If we go to second divide and look at the blue mark above the divide, that's e. And e is very similar to pi. Pi is just a number. It's an irrational number, but it is a number just the same. And e is 2. So we have to treat e just like we would treat pi. And so we are asked what is 2 to the pi power. So it's going to be 2 raised to the e power. So I'm going to have to go to second divide, and that gives an e, and it's impossible to see on this screen, but 2 to the e power is what I'm looking for. Hit enter, and I get 6.581 because it tells me directly round to 3 decimal places. So the answer for number 4 would be 6.581. 5 and 6 are graphs, and we just need to take a look at what does each one of these do. And we have to remember the transformation rules and stuff like that. So we get example number 5, f of x is equal to e to the 2x power. Okay, now first thing, it is an exponential because we have to the power, so we know it's going to go through 0, 1 unless something else causes it to be reflected or whatever. This says we're going to stretch it to 1/2 of its normal size, but what I'm going to suggest you do on exponentials is just plug in some values and see what you get. For example, if I plug in the value x equals 1, that would be e to the second power. Well, if we go to our calculator, there's actually e to a power, and that is second ln over here next to the 4. And that gives us e to a power. Well, I want e to the second power since I'm looking at x equals 1, so I'm going to put in a 2 there, and then just hit enter, and I get 7.38. So I'm going to come back over here to my graph and go to 7.38. 3, 4, 5, 6, 7. So that's way, way, way up here. Then I'm going to do the same thing for -1. I'm going to plug in what is e to the -2 power. So I go back to my calculator and find that second natural log, that's what the ln, raised to the -2 power is equal to what? 0.135, so a very small thing here. So 0.135 is going to be there, and we know that since it is an exponential, it's never going to cross the asymptote, which beginning wise is always y equals 0. And so we get this as our final graph. Example number 6. Five e to the x. Well, here, if we plug in 0, let's think about this. If we plug in 0, 5e to the 0 power. Well, anything to the 0 power is equal to 1, so that would be 5. So that is the equivalent of our 0, 1. And the asymptote is going to be 1 below that. Okay? So now let's plug in 1. 5 e to the first power, or what is 5 times e? So all I'm going to do on my calculator, and I'm not going to bring it up this time, but I'm going to take 5 times, and then I'm going to do second divide to get e, and 5 times e is 13.6. So that's way, way, way up here. I ran out of room way too soon, but that's where that one is. And if I plug in -1, this would be once again 13.6. And if I plug in -1, 5e to the -1, and plug all that into the calculator, I get 1.84, which this asymptote had no business being there. What I said was wrong. 1.84. So that would be about there. The asymptote is still going to be here at 0. It just looks a little bit different. You don't want to try and do transformations here. Because it just becomes too hairy too fast. So just plug in some numbers and go with that and see where we end up with. Continuing, and graphing will not be really emphasized, but you do need to know how to do them. But it certainly is not the emphasis for this particular section. Okay, let's go to example number 7. Grocery store normally sells 8 jars of caviar, and we're given that function there. And we're going to use this to find what is the probability of selling 4 jars in a week. Okay. Basically, we have this Poisson distribution, and just realize this deals with probability. And anytime this comes up, this will be given to you. And basically, selling 4 jars in a week, we want to find what is P of 4. So that would be 8 to the 4th power times e to the -8th power over 4 factorial. Now we need to remember 4 factorial means 4 times 3 times 2 times 1. It's all these numbers multiplied together all the way down to 1, all the integers. And so plugging in some numbers here, we get, and I'm going to just plug this all into one big calculated problem. And so this becomes 8 raised to the 4th power, so that's raised to the 4th power, times e raised to the -8 power, so I'm going to use the second natural log, that's e raised to the negative 8 power. I need to make sure I hit negative, not minus. And I'm going to divide, and I'm going to do a quick calculation here. 4 times 3 times 2 times 1 is 24. So I'm going to actually divide by the number 24. If I didn't do that in my head, or if I didn't know that answer already, then what I would have to do is I would have to put 4 times 3 times 2 times 1 inside a set of parentheses, and I just find it easier to do it mentally. And so hit enter, and we end up with 0.057. And so if we interpret this, what is the probability that we're going to sell 4 jars in a week? We have a 5.7% chance of doing that. Number 8, to find the number E, I am not the least bit concerned with that, so we'll just skip that temporarily. Well, no, we'll skip that forever. So let's look at number 9. Number 9, we have the equation 4 to the negative x equals 1/16. And 9 through 13 we are asked to solve the equations. In order to solve the equations, what we need to do is we need to get all of the bases the same. We need to somehow get the left-hand base exactly the same as the right-hand base, and as soon as we do that, then we can set the exponents equal to each other and solve. Because remember, if we have an exponential expression, that means the variables are in the exponent, not in the bases. So if we get the bases the same, then the exponents will be forced to be the same. So I look at this, I have 4 to the negative x and 1/16. I notice that each of these can have a base of 4. So the 4 to the negative x is going to remain, and 1/16 is 4 to the negative 2 power. Remember that the negative puts it down here in the denominator, and 4 squared is 16. So it's relatively simple to get to that point. Now that the bases are exactly the same, that means the exponents have to be equal. Negative x equals negative 2, or dividing both sides by negative 1, we get x equals 2. And it is relatively simple at this point to just do a quick check. What is 4 to the negative 2? That's 1/16. A very easy check in this case. If we look at number 10, we are told 4 raised to the 3x minus 5 power is equal to 256. And once again, with a little bit of practice, it doesn't become too difficult to realize 4 is the base we want. A lot of times, the smaller number will be the base we want, but sometimes we have to take both of them even smaller. For example, we could, if we really wanted to, take this to a 2. But as it turns out, 256 is actually equal to 4 to the 4th power. And that's the first thing I would check. Is 4 to some power equal to this, equal to the 256? In this case it is. So set each of the exponents equal to each other. 3x minus 5 equals 4. Add 5 to both sides, and divide both sides by 3 so that x equals 3. Once again, it would not take too much to do a quick check, but I am going to forego that particular step. Example number 11. 2 raised to the x squared minus 3 power equals 64. Hopefully it's not too difficult to realize 64 is a power of 2. So I'm going to do 2 to the 6th power, because that's what 64 is. I've had the bases the same, so that simply means x squared minus 3 has to equal 6. It doesn't take too long to add 3 to both sides. X squared equals 9, and so taking the square root of both sides, x would equal both positive or negative 3. We need to remember that when we take the square root of a number, we have to include both the positive and the negative on both of these situations. Now, number 12. Number 12 is 625 raised to the 3x minus 1 power equals 3,125 raised to the 5x power. Now we have a slight problem here. Regardless of how hard we try, 3,125 is not a power of 625, so what we actually have to do is we have to break these down a little bit further. Hopefully it's not too difficult to realize that 625 is actually 5 to the 4th power. So we can actually change 625 to 5 to the 4th power, but that was already being taken to the 3x minus 1 power. Likewise, 3,125 is 5 to the 5th power, but it was already being taken to the 5x power. Now we need to remember our laws of exponents, saying whenever we take a power to a power, we're going to multiply the exponents. So we get 5 raised to the 12x minus 4 when we distribute that 4, and when we take 5 to the 5th power raised to the 5x power, that is 5 to the 25x power. Now that the bases are the same, we can now set the exponents equal to each other and solve from there. Subtract 12x from both sides and we get 13x minus, whoops, let's try that one again. We get, subtracting 12x from both sides, we get negative 4 equals 13x, and dividing both sides by 13, x equals negative 4/13. Now obviously here, this is not quite as simple to check, but it is doable just the same. Example number 13 finishes this type of problem, and we deal with e. But once again, e is no different than any other number, except we don't actually write it all out. So it's e to the x times e to the 28 equals e to the 11x. Now this would be all fine and dandy if we only had one e on the left hand side. So we need to remember our rules of exponents. First of all, e to the x is e to the x squared times e to the 28th equals e to the 11x. Once again, we still need to get rid of the two e's that are on the side, because in order for us to solve these equations, we need to have the same base but only one base on each side. And so, remembering the remembering the rules, when the bases are the same, what we do is we do not multiply the exponents, we add them. So this becomes e to the x squared plus 28 power equals e to the 11x. Now we have e, just one e on either side, so that means the exponents now have to be equal to each other. X squared plus 28 equals 11x. We're going to have to solve this using the trinomial that's going to result. So I'm going to subtract 11x from both sides, setting it equal to 0. And as I look at this, I see that I can factor this, and this factors to x minus 7 times x minus 4. And so setting each one of these equal to 0, I see either x equals 7 or x will equal 4. Now, one thing we do want to check out pretty quick is, well, let's see, if x equals 7, 49 and 28, yeah, that one seems to work, and 4 would be 16 and 28, yeah. So x equals 7 or x equals 4. Here's actually one of the, this is only the second time that we've gotten two answers. Once again, the check will bear out that that is indeed what the answers are. Example number 14. Number 14, we know that 48 minutes, it was completely full. 3 minutes earlier, since it doubles every 3 minutes, so 3 minutes earlier, it was only 1/2 full. And it asks how long did it take before it was a quarter full. Well, 3 minutes earlier, we would have had half of a half, which is a fourth. And so here is just a situation. We could have gone through the whole function and all that stuff, but truly, just think it through. And any of these types of problems, you will get this type of problem, or you will be given the function that is necessary to solve it. Example number 15. We are going to use A equals P times 1 plus R over N, that quantity raised to the NT power, and all of the information is given there. A is the final amount, P is 6,000, the initial deposit. So it's just really a matter of plugging it in and calculating. So we're going to put in P for 6,000, 1 plus, okay, R is 0.07. N represents the number of times it's compounded, and since it's compounded quarterly, it's to the 4th power. And then we need to take NT. Well, N is 4 and T is 5, the number of years. And so it becomes 6,000 times this quantity raised to the 20th power. And honestly, you just plug this right into your calculator and do some rounding, and you get $8,488.67. Once again, as you plug this into your calculator, make sure you do include the 1 plus 0.07 over 4 in parentheses. And it certainly wouldn't hurt to put a multiplication symbol between the 6,000 and the fraction or the parentheses, but it actually should work with or without that. So just keep that in mind when you actually punch this into your calculator. And finally, example number 16. Example number 16, we have f of x equals 4 to the x power plus 3. First question is, what is f of 2? Well, that's pretty simple. F of 2 is 4 raised to the 2nd power plus 3, which is 16 plus 3, or 19. So we've answered the first question. What point is on the graph of f? And this is a very elementary question at this point, because we will have needed to have done this in order to graph, and secondly, this is something you could do way back in Algebra 1. So the point would be the point 2, 19. Now there are infinitely many other answers, but why would you do more work? I mean, honestly, here is your answer. The x value is right there. There's your y value. 2, 19.